Hello students, in previous video we have seen Hayes law constant heat summation and numericals based on it. In today's video we are discussing about spontaneous or irreversible process. How it is defined? A natural reaction in which driving force is very large in comparison of opposing force, and which occurs only in one direction, especially forward direction. Without influence of external agency, is called spontaneous or irreversible process. What is definition of spontaneous process? A natural reaction in which driving force is so large as compared to opposing force and which occurs only in one direction, forward direction, without influence of any external agency. It is called spontaneous process. Key points of spontaneous reaction. First, it is a natural process which occurs only in one direction, without influence of external agency. Second point, in spontaneous process, driving force is very large as compared to opposing force. Hence, direction of the process cannot be reversed. By infinitesimal infinitesimal in opposing force. Driving force is so large as compared to opposing force, and therefore direction of the reaction cannot be reversed by infinitesimal increase in opposing force. Next point, spontaneous process takes place of its own accord. Till equilibrium is attained. And generally in spontaneous process equilibrium is attained at the end of the process. This spontaneous process takes place of its own accord till equilibrium is established. It tends to occur in a direction. Spontaneous process tends to occur in a direction that leads to equilibrium, and system goes to lowest energy state. Fifth point, spontaneity is independent of rate of the reaction. Hence, spontaneous process may be slow or fast. And last point, both exothermic and endothermic processes are spontaneous. Spontaneous process can be explained with the help of some key points. First, natural process which occurs. Spontaneous process is natural process which occurs only in one direction without influence of external agency. In spontaneous process, driving force is very large as compared to opposing force. Hence, direction of the process cannot be reversed by infinitesimal increase in opposing force. Spontaneous process takes place of its own accord till equilibrium is attained. Spontaneous process tends to occur in a direction that leads to the equilibrium, and system goes to the lowest energy state. Spontaneity is independent of reaction rate. Hence, spontaneous process may be either slow or fast. Both exothermic and endothermic processes are spontaneous. These are some key points which are useful to explain spontaneous process. Some examples we will discuss about. Examples. First example, neutralization reaction. Reaction between acid and base produce salt and water is called neutralization, and here neutralization between HCl, neutralization between aqueous solutions of HCl and NaOH to produce NaCl plus H2O. This reaction is spontaneous and enthalpy change of this reaction is minus 57 kilojoule per mole. Here it is exothermic fast reaction. Second example, dissolution of solid NaCl in water. NaCl solid when dissolved in aqueous medium, that is water, aqueous solution of NaCl is formed, and this reaction is, or enthalpy change of this reaction is plus 3.9 kilojoule per mole, and this is endothermic fast spontaneous reaction. Third example, flow of water from higher level to lower level. Till equilibrium between two levels is attained. Fourth example, fusion of ice or melting of ice by absorption of heat above 0 degree Celsius. It is endothermic process. Endothermic process. Fifth example, hot coffee cools down due to liberation of heat to the surrounding. These are some examples which are examples of spontaneous processes. Next point we have to discuss about factors affecting spontaneity. Of reaction. First factor, energy of reactants and products. spontaneous process takes place. Spontaneous reaction takes place in a direction in which energy of the system decreases. That means if higher energy state system is present in higher energy state, it goes to lower energy state spontaneously. Generally, direction of the process depends upon enthalpies of reactants and products. If enthalpies of reactants are greater than those of products, then forward reaction is spontaneous. And if enthalpy of reactants is less than those of products, then backward reaction is spontaneous. This is very important point. Here in case of exothermic reaction, in case of exothermic reaction, HP is greater than HR. HP is less than HR, and therefore delta H, which is HP minus HR, it is negative. Here in exothermic reaction, system goes from higher energy state to lower energy state, and therefore enthalpy change is negative. But in endothermic reactions, HP is greater, enthalpy of products is greater than those of reactants, and therefore enthalpy change of this endothermic reaction is positive. From this explanation, it is clear that most of the exothermic reactions are spontaneous because during these reactions enthalpy or energy of system decreases. But there are some exceptional examples of endothermic reactions which are also spontaneous. We see some examples. First example, fusion of ice above 0 degrees Celsius. Here, this is endothermic process. And therefore enthalpy change is positive. In previous video we have seen enthalpy of fusion of ice at 0 degrees Celsius. Second example, dissolution of NaCl. Dissolution of solid NaCl in water. We have seen this example. Here, NaCl solid plus aqueous to give NaCl aqueous, and enthalpy change of this reaction is 3.9 kilojoule per mole. Here enthalpy change of this reaction is positive, therefore it is endothermic process. Third example, neutralization of aqueous HCl by aqueous NaOH. Here HCl aqueous plus NaOH aqueous to give NaCl aqueous plus H2O liquid, and enthalpy of neutralization is minus 57 kilojoule per mole. This is exothermic reaction. These are some examples of exothermic and endothermic reactions which are spontaneous. That means enthalpy change, either it is negative or positive, it don't decide spontaneity of the process. Some other factors are also responsible for spontaneity. Second factor we have to discuss about, it is entropy. Entropy is thermodynamic function or property which measures disorder or randomness in the system. It is denoted by S. It measures randomness or disorder in the system. Molecular disorder. It is denoted by capital S. Third, it is a state function. Its magnitude depends only on initial and final states of the system, and not on path followed or number of steps followed. Fourth point, being a state function, exact value of entropy cannot be determined. Entropy cannot be determined, and hence change in entropy denoted by delta S is taken into consideration. That means delta S is equal to Sp minus Sr. Fifth point, entropy is directly proportional to randomness. Randomness or disorder. Sixth point, entropy of solid is less than liquid. Liquid is less than gas. Entropy of the system increases from solid to gas via liquid. To know what happens during change of physical state of substance from solid to gas, either entropy increases or decreases. To know that this fact, we can take an example of ice. H2O solid means ice. In these, molecules are arranged in definite pattern. That means low entropy due to more order state. You can show orderly arrangement of water molecules in ice like this. When it is heated, it gets converted into liquid water. Some of the hydrogen bonds between the water molecules in ice get broken due to absorption of it, and disorder increases, and therefore entropy also increases. High entropy due to disorder state. You can see these molecules little bit apart from one another. This is liquid state, this is solid, this is liquid, and when liquid water is heated further, it gets converted into water vapors. Here, all the hydrogen bonds between the water molecules in liquid water gets broken during evaporation, and therefore highest entropy this system has highest entropy due to more or highly disordered state. Disordered state. Here you can show these water molecules very apart from one another. This is gas. In this way, when physical transformation between the states of substance takes place, generally it is observed that entropy increases when solid is converted into liquid and liquid is converted into gas. On the other hand, if gas is cooled to liquid, entropy decreases, and liquid is frozen into solid, entropy still decreases. This is about entropy change. There are some examples of the reactions in which you can know whether entropy change of the reaction is positive or negative. Entropy change positive or greater than 0. It is indication of spontaneous process. Delta S negative or less than 0 is indication of non-spontaneous process. Some examples are there. I2 solid plus water to give I2 solution. Aqueous solution of iodine. Here, solid is converted into liquid. That means solid is converted into liquid. Therefore, entropy change of this reaction is positive, or you can write as delta S greater than 0. Here, this is ordered state. Iodine is in solid state, it is in ordered state. But when it gets converted into liquid state, that means it comes in disordered state. Disorder increases and therefore entropy of this process is positive. Second example, H2 gas gets converted into gaseous hydrogen atoms. Atomization. Here, this is ordered state, and during atomization it gets converted into disordered state. That means here disorder increases in this reaction. Although both are in gaseous state, but molecules are broken down into gaseous atoms, and therefore entropy of this reaction is again positive or greater than 0. Third example, twice H2 gas plus O2 gas, it gets converted into twice H2O liquid. Now here this is disordered state, and it is converted into ordered state. That means entropy, as disorder decreases, entropy also decreases, and therefore entropy change of this reaction is negative or less than 0. It is also spontaneous. Fourth example, calcium carbonate solid. This is ordered state. When it is heated, it decomposes into calcium oxide solid and CO2 gas. Here solid is converted into gas, and therefore this is disordered state. Disorder in this reaction increases, and therefore delta S is positive or greater than 0. And fifth example, decomposition of H2O2, hydrogen peroxide liquid. It gets converted into twice H2O liquid plus O2 gas. Here liquid is converted into gas, therefore this is disordered state, and this is ordered state. Disorder increases, and therefore entropy of this reaction is again positive or greater than 0. In this way, depending upon physical transformation, you can predict whether given reaction has entropy greater than 0 means positive or less than 0 means negative. If delta S is exactly 0, then system is in equilibrium. Next point we have to discuss about quantitative definition of entropy. Actually, entropy cannot be defined, but it can be mathematically defined. What is definition? An entropy change. An 16 which is equal to amount of heat Q reversible transferred to heat in a reversible manner divided by temperature in Kelvin at which heat transfer takes place. Question may be asked, what is entropy? An entropy change of a system which is equal to the amount of heat transferred in reversible manner divided by temperature at which heat transfer takes place. It is called entropy, and formula for entropy change is delta S is equal to Q reversible divided by capital T. This formula may be used to solve some problems on entropy change, amount of heat transferred and temperature. Here generally we have seen entropy. Third factor we have to discuss about effect of temperature. Effect of temperature. Here generally delta S is directly proportional to temperature, because if temperature of the system increases, kinetic energy increases and therefore motions of the system also increases, randomness increases and therefore entropy also increases. Generally, if here you can see exothermic reactions are favored by low temperature. Exothermic reactions are favored by low temperature. That means if temperature goes on decreasing, exothermic reactions become more and more spontaneous. On the other hand, endothermic reactions are favored by high temperature. That means if temperature of the system increases, endothermic reactions become more and more spontaneous. Now here, at low temperature, more and more heat can be added into the system and therefore randomness increases in the same proportion and entropy also increases. That means at low temperature heat is added, entropy remains directly proportional to temperature, because here if system is already present at low temperature, more and more heat can be added, and in the proportion of heat added, randomness also increases and therefore entropy increases. That means entropy change is directly proportional to temperature only at low temperature. But at high temperature, system a very small amount of heat can be added into the system at high temperature, and therefore although randomness increases, but it is not in the proportion of temperature increase, and therefore delta S is inversely proportional to temperature at higher temperature. In this way, effect of temperature on the entropy can be spontaneity. effect of temperature on the spontaneity can be explained. We have seen three factors which affect spontaneity. First, energy of reactants and products. Second, entropy. And third, effect of temperature. Some more factors are also there. Collectively, all these factors affect spontaneity. Thank you.